So when we're looking at these, this rule, the fractional indice rule, what we're looking at is we're basically looking at, we have 1 over the m. So it needs to be a 1 in the numerator when we're talking about this indice. And the m basically becomes the power of the root that we're doing. So for example, if we've got 4 to the power of a half, it's the square root of 4. Now we don't write 2 there, we just write the square root, and that obviously equals 2. If we've got 8 to the power of a third, it's the third root to the cube root of 8, which is going to be 2. So if we've got a quarter, we're looking for 4 numbers that multiply each other to give them 16, which is going to be 2 by 2 by 2 by 2. One of those would be 2. Here, we're looking for 5 numbers that multiply by itself to give us 32. That would be 2 by 2 by 2 by 2 by 2. So just 1/5 of that would be 2. Here, we've got the square root of 16. Well, we've got 16 to the power of a half, which is square root of 16, which is 4. Now we know that if we said, well, 16 to the power of a half would be the same thing as 16 to the power of 2 quarters, because 2 quarters is the same thing as a half. So what you can do is you can actually take out and use one of the indice laws and make that as a quarter times to the power of 2, which gives you 2 quarters. Okay, so when you've got this rule here, basically you've just taken out that. Now, now we know that we can actually, because it has a numerator of 1, we can actually do the 4th root of that. So that is going to be the 4th root of 16 all squared. And that means it's 2 squared, which equals 4. So this rule here is probably one of the hardest ones to get your head around, this example 6, because it does get a bit tricky. The main thing is just to take out the numerator, make it a power, so then when you multiply it back in, it will work out. This needs to be the power of 1. So I will unpack this a little bit more, but I'm just going to give you another example. So if I have 32 to the power of 3/5, that actually equals 32 to the power of a fifth cubed, because when I multiply that, that's going to make it 3/5 because you multiply them together, the indices. Now I know that is the 5th root of 32. The 5th root of 32 is actually 2, and then we're going to cube that. So that equals 2 cubed, which equals 8. Now, let's look at this a little bit differently of what we're actually doing. When you think about an indice, right, like if you think about what an indice is, an indice is a number. So I'm going to start a new page. Or back to there. So when you're thinking of a indice, if I said, hey, you know, what's, let's stay with 2, what's 2 to the power of 4? We would say, hey, that means, you know, this thing is multiplied by itself 4 times. If I asked you, hey, what's 16 to the power of 3? Well, you'd say, hey, 16 is multiplied by itself 3 times. So if I said, okay, well, what's 16 to the power of a quarter? Well, if you think about it, here, if I just asked you what is 16 to the power of 1, well, you just say it's 16 times by itself, right? 16 to the power of 2 is 16 by 16. So if you start getting into fractions, so we're not going to 0 because then it obviously goes to 1 and then it goes to on, you know, remember if you've got 16 to the power of 0, that will equal 1 because you're dividing by 16 every time. 16 to the power of -1 would equal 1/16. 16 to the power of -2 would equal 1/16 by 16, and so on. But we're looking at what happens when we get these fractions, okay, in between these sort of steps. Well, if you've got 16 to the power of a quarter, aren't you really looking for like a quarter of its power that gives it 16? So we've got 2 by 2 by 2 by 2. You need a quarter of that. 2, 4, 6, 8. A quarter of a number that gives you the 16 is just 2. So if I say, hey, what's 16 to the power of 3/4? Well, I'm thinking of 4 numbers that multiply to give me 16. Well, that's going to be 2 by 2 by 2 by 2. And 3/4 of that would be there, because that would make up the whole, right? So it's 2, 4, 6, 8. Which 2, 4, 6, 8, I should say. So that would equal 8. So another way I could say it is, you'd be fine if I said, hey, if I said to you, what's 16 to the power of 1? Well, we know 16 to the power of 1 is 16. So if I say what's 16 to the power of 4 on 4? Well, what I could say there is that's like we've broken it up. So that's really like 2 by 2 by 2 by 2. And it takes 4 of these numbers. That's why we cube root it. So that's why we would actually do this. If we have to do this, we're going to do the cube root of 16 and then cube it. Don't forget. Oops, I skipped a step. Let me just do that again. We actually are going to do 16 to the power of a quarter, which is the cube root of 16, and then to the power of 4. So what we find is we actually do that, which tells us that it's 2. And then we cube it. So one way to look at this is really we need 4 numbers that multiply to give us the whole of 16, which would be 2 by 2 by 2 by 2. So that's the cube root, because that's what we're trying to do. It's exactly the same thing as the cube root here. So this denominator is exactly that. And then what we do is we look at the numerator, and the numerator's just been moved out here. Now we know we need 4 of those, 1, 2, 3, 4. So like this before, we cube root 16 because we know we need 4 numbers to give us the whole, but we only want 3 of those, 2, 4, 8. So that's another way to look at it. Yeah, I've sort of made up that one myself because to me it made sense. The way in the textbook you'll see it will be this sort of style when you're trying to simplify them. So that's sort of, yeah, that's where we're at with the basically those. So let's just look at another. If I said 16 to 3 on 2. Okay, have a think about what you think that answer will be. Go about it both ways for me, and we'll see how that works out for you. You guys have a go at that one, and I'll go through it. I'd like you to do this way and that way. Please put your answer in Teams when you get there. Okay, how did you guys go with that? Any questions? Let's choose someone. How did we go? What do we get? 64. Looks all right. So let's have a look at this. So there's a few ways you can go about it. So the first thing is we could do it as 16 to the power of a half to 3. Why does that work is because then you can use your multiplication of 3 times a half is 3.5. So we know now it's 1, so we can actually do the square root of 16. Now, don't put the 2 in, but I'm just putting it there sort of in a dashed line just to show you that there is normally a 2 there, we just don't write it. And that is all to the power of 3. The square root of 16 is going to be 4. I need a bit more room, excuse me. That's going to be 4 to the power of 3. So that is going to be 4 by 4 by 4, which is going to be 64. The other method I'd like you to have recorded down, which you won't really find in textbooks, is I suppose what we're really looking for is we know that 16 to the power of 3 on 2 is really two numbers to give you 16 that multiply by each other. It would be 4 by 4 by 4. So that would be 64. So it's a bit trickier, but you could annotate it if you like to. So let's just give ourselves a bit more room down here. So this many numbers to the number, this many numbers to multiply, this many of the same number, I should say, to multiply to 16. That equals 4. And then this one is, so that'll be the first thing you do. And the second thing is you do this many 4s multiplied. So it'll be 4 by 4 by 4. I like to think this because it kind of makes a bit of sense to me. Like otherwise it's just a bit of a rule. It's like, well, why do we square root it? Why do we have to do it? But when you think about it, because it's like a half, if you think of it as a half, well, 4 by 4 gives you 16 because you're talking about indice powers. So it makes sense. It's 4, but then it's going to be 4 cubed. So that's why you've got 3 on 2. That works with that. It won't work when you get into a bit of higher order thinking. When we get to a bit more higher order thinking of things like this that you're going to get to. So you're going to get things that won't apply where you don't know what the indice is. So if I ask you what this is, well, because it could be 16, it could be 24, it could be whatever, you don't know what that is. So I do know that that is, though, like the square root of a to the power of 3. So I can justify that. Some other things that you might find, I suppose, a little bit trickier. You might have like a to the power of 5 on 2 divided by a to the power of, whoops, that's d, divided by a to the power of, let's go with a 2/3, and I'll ask you to simplify this. And you might be like, what? But don't forget, when we divide, we subtract the indices. So that's a to the power of 5 on 2 minus 2 on 3. Now we just treat this the same way as we do with fractional indices. So with fractions, so that is a. We've got to find the common denominator. So that is going to be 15 on 6 minus 4 on 6. That is a equals 11 on 6. And if it was a number, it would be the 6th root, but you'd leave it like that. If it was a number, though, you could definitely simplify it. So there's a few of these extra other power ones that we do. Don't forget, it could also be like a to the power of 3/4 multiplied by a to the half. If that's the case, remember we add these indices, so it's a 3/4 plus a half, and that is going to give you a equals, that's going to be 2/4, so that's going to give you 5/4 as well. These are in the textbook as well, these explanations, so I'm not really going to go through them too much, but I'm just going to quickly go through one. And then you could also have like a to the power of 3/5, to the power of let's go with 6/4. Now remember, you multiply these, so that is going to be a equals 3/5 multiplied by 6/4. So we're just using all the same indices laws. So that is going to be what are we looking at? 18/20, and we can simplify that. That's going to be 9/10. And that's it. That is that chapter. So what I'd like you guys to do now, probably for the next 20 minutes, please just go through and have a go at the questions just on the lesson plan from 6H. I think the lesson plan should be up there. I was having some issues with it. Have a crack at that one, see how you go. And that is